The sample lies at the heart of survey research. It's often called a miniature of the population, and the process of drawing a sample should maximize the similarity between the sample and the population under study. So how do we achieve this goal? There are two approaches to drawing a sample: non-probability and probability sampling. Probability sampling gives all units in the target population a chance of being selected to be in the study, and the probability is known. For example, if you have a list of 10,000 members of your target population and you randomly draw 500 people for an interview, each member of the population has a 5% chance of being selected for the survey sample. Let's look how to draw a probability sample and why it matters that the sample is drawn randomly.
Let's imagine that this is a population, and each of these dots represents an individual, and the colours represent a measure of socio-demographic diversity of people, like ethnicity or age group. To obtain a good survey sample, first you must determine a target population, and to do that, you have to define spatial and temporal boundaries, so a geographic area and a time period. For example, it could be that we are interested in studying people living in Sheffield who have visited a cinema in the last 6 months. The second step is to find the most suitable sampling frame. This is a list of all the individuals in your target population. Now, having clearly defined the population you want to study, you can proceed to drawing a sample. The basic principle you follow is to obtain a representative sample, which means getting a smaller group, which would be a mini version of the population you study. Why is it so important that the sample resembles the whole population? Only when your sample and target population have similar characteristics can you generalize the results of your survey to the whole population. So you want to end up with similar percentages of people with different demographic traits, such as gender, age, and place of residence, as well as different preferences, opinions, and attitudes within your chosen area. The best way of achieving this representativeness is to select individuals randomly. Random sampling gives each object an equal chance of being selected. If you followed any non-random pattern, like asking your friends or designing a quota, your sample would not represent the population well, and your estimates based on this sample would be biased. We could compare this procedure to the process of tasting soup. If you want to try soup to check whether it tastes good, you don't need to eat the whole bowl. If it's well mixed, a random try of just a spoonful will tell you whether it's tasty or not. Random sampling approaches work best when you have to make conclusions about the whole population, such as finding out how many of the dots in the population are blue. If you want to investigate differences between specific groups that you know are different sizes, you should take a different approach. Let's say that we want to compare differences in political attitudes across different ethnic groups. Each colour here represents a different ethnic group, and one of the groups is much smaller. Random selection from the whole population would mean that we will receive a very small number of people represented by the blue dots, and this group is unlikely to be internally diverse enough in terms of other traits, like age or geographic coverage. Instead, you could draw a stratified sample, which means that you have to divide the population into subgroups, each representing the ethnic groups. Since you want to measure differences to the same degree of precision, subsamples drawn from each subgroup should be of the same size. Now you randomly select your individuals from within these subgroups. Your sample is stratified and should be highly representative for each subsample thanks to the random selection. So in this example, it would allow you to precisely investigate differences in political attitudes between ethnic groups using a survey method. In summary, we have explained a few crucial steps that should be undertaken in designing a sample for a representative survey. If your population is clearly defined, you know who, what, where, and when you want to study, then you can select the best sampling frame for your target population and randomly draw a sample. And that is sampling, something relatively simple which can have a profound effect on the reliability of a study.
In non-probability sampling, the chance of being selected is not known, and some units may not be given any chance to be selected. Let's return to the list of 10,000 people. To draw a sample in a non-random way, You could select first 500 people on the list, or only those that live near you. When you do not have a good sampling frame on when your resources are limited, non-probability sampling could be a better or even the only solution. The most popular non-probability sampling is quota sampling. This is where specific shares of interviews for the most important demographic characteristics are established beforehand. Researchers decide how many women and men, people of different age or different ethnicity they want to interview. In practice, research companies will mix random and non-probability sampling techniques by employing random root quota sampling. So they will start by drawing a random list of addresses and then interview people according to the quotas that they have to fill, but they may skip some addresses on their list to prevent too high clustering of respondents in one neighborhood. This type of sampling method is cheaper and less time-consuming than probability random sampling. Other types of non-probability sampling include convenience sampling, when the most accessible members of the target population respond to the survey on a first-come, first-served basis, for example, through street recruitment, and the other one, snowball sampling, where respondents invite their friends and family to participate in the survey. These sampling methods do not produce information which is representative for your target population, because some subpopulations could have been excluded from your sample. This means you can't generalize your results of the study on the whole population and conclude that this is how the reality works. However, these methods are good for difficult-to-reach groups and for research on new and sensitive topics, such as drug use, addictions, or undocumented migration. In sum, whether to use probability or non-probability sampling depends on who your target population is, whether you have a good sampling frame for those people or institutions, and, as often in the case, how much time and money you have.